Hi everyone, welcome to Algebra 2, Lesson 2-6, the quadratic formula. In this lesson, you'll be able to solve quadratic equations using the quadratic formula. The important vocabularies are discriminant and quadratic formula. So first, let's look at exploring reason to think about the concept and get you introduced to the idea. You can complete the square to solve the general quadratic equation ax squared plus bx plus c equals c. First of all, what is this form? Ax squared plus bx plus c. This is the standard form, right? We learned that. We learned all the types of forms of a quadratic function. And we just learned how to complete the square in the quadratic equation in the last lesson, right? So in order to complete the square, you have to make it into a perfect square so that you can use the perfect squares to factor them out. So let's look at this example. Justify each step in this general solution. So if you look at the first example, the first step, it's just the original equation. And then what happened the next step? We subtracted c on both sides. So this is the process of completing the square. But we're doing it without knowing what a, b, and c are. And we're just assuming that a, b, and c are certain numbers. And we're just treating them as numbers that we don't know. So as a variable, right? As variables. And then what's the next step in completing the square? If you understood the last lesson, you would know that you'd have to figure out negative b over 2 squared. So that we can add negative b over 2 squared here to 8 squared on both sides to balance the equations so that we can complete the square. So is this okay? Let's look at the third step. It's kind of blurry right now, but what they did is that they divided all terms by a because you have ax squared and we want x squared to complete the square, right? So we divided a on all the terms on both sides. So we got b over ax equals negative c over a. And now we're completing the square by getting negative b over 2 squared. But because your b here is b over a, we have negative b over a divided by 2 squared, which is just basically b over 2a squared, right? And so we add that number that will complete our square, and then we can factor it out. It's going to be b over 2a, x plus b over 2a squared to factor this perfect trinomial out. And then we have this variable here where we had negative c over a from all these steps, and then we added b over 2a squared. And so we can just simplify them. And if we do that, we can change the order as well. And then since we have a x plus b over 2a squared, we can square root this and square root both sides, and we can get plus or minus square root b squared minus 4ac over 4a. Yeah, so it's kind of hard to see, right? So on the last step, what you get is the quadratic formula. But here, this is really, it's kind of hard to see the second to last step. X plus b over 2a is equal to plus or minus square root b squared minus 4ac over 4a squared. And where did 4 come from? From this one. So if you have b over 2a squared, you square it. And that's going to be b squared and then 2 squared and a squared, right? So here if you square b over 2a, you get b squared over 4a squared. Does that make sense? And then you subtract c over a. But you can combine this fractions by rationalizing the denominators. So this fraction c over a already has a, and the first fraction has 4a squared. So you can multiply the second fraction by 4a to make the denominator equal to each other, and then you can combine the fraction. And this is what we have right now. And at the end, your quadratic formula is negative b plus our minus square root b squared minus 4ac over 2a. And so yes, all these steps are justifiable. Let's write them down. We need to find a space. Let's write it here on top. So explore and reason, part A. So in step 1, it is the general form of a quadratic equation where a is not equal to 0. And then step 2, you can subtract the constant term c from each side. Step 3, we divided each side by a. And then step 4, what did we do? We added b over 2a squared to each side to complete the perfect square trinomial. And then step 5, we factored the perfect square trinomial on the left side of the equation and simplified the expression on the right. And then step 6, we found a common denominator and we added fractions. Step 7, take the square root of each side of the equation. And step 8, the last one, we subtract b over 2a from each side of the equation. And now we have a quadratic formula. This is part A. So what must be true of the value of b squared minus 4ac in this formula at the end? If the equation ax squared plus bx plus c equals 0 has two non-real solutions. If it has two non-real solutions, then we know there must be imaginary numbers. So b squared minus 4ac could be negative, right? Yeah. If it's non-real solution, if this is negative, and if they're positive, it will just have one solution. It could have two solutions. If it just has one solution, what does that mean? Could we have one solution? Yeah, there's a case. There's one special case when your radicand equals 0. B squared minus 4ac. If that is equal to 0, it's just going to be one solution, right? Because you add 0 and minus 0 is still going to be the same number. So x would have one solution, right? So let's write that down. The equation will have two non-real solutions if the radicand b squared minus 4ac is negative. And it will have one solution if the radicand equals 0. Radicand, which is b squared minus 4ac. Okay, so this is the introduction to the quadratic formula. This is how we got a quadratic formula. In some textbooks, there are quadratic formulas introduced. And you learn about quadratic formula, but you don't know where it came from. It's actually the same thing. It comes from the standard form. You just solve for x using the standard form and of the quadratic equation, and you get a quadratic formula. Okay, so I know you may not be able to understand everything right now as to how and why we're using a quadratic formula, but it will make sense. It will make sense more in the future as we use this. Okay. So the essential question for this lesson would be, how can you use the quadratic formula to solve quadratic equations or to predict the nature of their solutions? Let's continue with example 1 in the next video.